So let's start the session. This is week 8 session, week 8 online live session for the NPTEL course on Urban Utilities Planning, Water Supply, Sanitation and Drainage. This course is offered by Dr. Devapratim Pandit. He is a professor in Department of Architecture and Regional Planning at IIT Kharagpur. I am the teaching assistant for this course. I am Vapak Kabadwal. I am a research scholar in Department of Civil Engineering at IIT Madras. So this week we will study about sanitation and drainage. We will solve some problems, MCQs, fill in the blanks, and match the following. So first we'll understand about sewage, drainage, and sewers. What is stormwater? And what are sewers? So basically, sewage contains black water. It is also basically it contains black water plus black water that is from toilets, and it can also contain sewage that is from kitchen and bathroom waste. Kitchen and bathroom wastewater. So mainly it contains black water that is from toilets. That is sewage. Stormwater. Stormwater is mainly is due to rainfall. That is stormwater. And so we supply, so sometimes that we'll discuss, like sometimes the stormwater, these both are added. That's it, this is sewage. They can be added A plus B. These are called combined sewer. Sometimes they both are combined and combined in one pipeline. One pipeline. This is called combined sewer. Combined sewer. Sometimes they are provided separate lines are provided. These are called separate sewers. You can imagine why when they are combined, when they are provided separate. So another one is partially separate sewers. So in so that I can say sewage plus drainage, sewage, drainage, and drainage here, sewage plus drainage means in this third case some part of drainage from rooftop and paved area is allowed to pass through this sewer pipe. Rooftop water plus from paved area is allowed to mix with the sewage. So this is called partially separate sewers. And that you can think combined sewers means when rainfall is less, then there we can use combined sewers. When rainfall is very large, so then we have to provide bigger size of these drainage pipes. So why we are separating? Why separate sometimes? Why sometimes combined? Because stormwater has less BOD, less COD, and does not require does not require the extent of extent of treatment which sewage requires, and stormwater for sewage comparatively comparatively more BOD, more COD than stormwater. So requires treatment. So that's why when this stormwater is less, it can be combined with less, then it can be combined with sewage. When stormwater increases, it dilutes the sewage, and it and further we need to treat the sewage. So that's why we are trying to bifurcate. We are trying to provide separate lines for sewage and drainage. So that's why this is the philosophy of combined and separate sewage system. So while designing the sewers, that sewers we need to check what is the shape of the sewer. So while designing the sewer, we need to know what is the shape of the sewers. And one more important thing, sewers are what type of sewer, shape of the sewer, sewers, type of flow, slope, if gravity flow, diameter, or I can write here size of sewer, bracket dia or dimensions. Material and discharge. What is the discharge? Fluctuations. And type of sewage system. Type of sewage system we just now study. So if I write it like 1, 2, 3, 4, 5, 6, 7. Type of sewage system, these are three combined separate system and partially separate system. Shape, we can complete it easily. Shape, it can be circular, it can be egg-shaped sewer. Here like this. That we will discuss later. Shape either can be circular, egg-shaped sewers. The, yeah, and type of flow. So it can be gravity flow. Color. Type of flow can be gravity flow, or it can be pumped, or it can be vacuum flow. Slope, and if it is gravity flow, what slope we have to provide, and the size of sewer depends on the discharge and fluctuations, and the material we have to choose, whether generally we use concrete sewers because the constituents in sewers in sewage reacts with the metal. Generally we choose concrete sewers, and type of sewer system we study. So material, then size of sewer we have to calculate. Slope, this thing is that shape is also slope will depend on the discharge or flow. So that will depend on the discharge. Size of the sewer also depends on the discharge in the sewer. So now we'll focus on the discharge part. So that I need to make. So this is the, let's take, we are assuming circular sewer. Circular sewer. So it should have some slope like this. This is the slope. This is the dia, and through this some discharge will come, and the sewer will not be completely full. It will, thus, if it is flowing with the help of gravity, it is called open channel flow. So how we will distinguish between open channel flow and pipe flow or pressure flow? So the water will not be in any pressure. So there is no pump. There is no pumping. No pumping should be done, and the water should have. Let's say this is the water. So on in the interface between water and air, there should be only atmospheric pressure. Atmospheric pressure. So now we will talk about flow into the sewers. So flow what can be? First set is what is the flow and what are the fluctuations. Fluctuations can be daily. What type of fluctuations? Based on the consumption of water. Based on consumption of water, and it can be monthly. Monthly means seasonal variation, we can say, based on seasonal variation. Yearly variations are very less in general, and the flow in this velocity in sewers can be calculated using Manning's equation, which is velocity is equals to 1 upon L r to the power 2 by 3 s to the power 1 by 2. So this is the velocity or open channel flow. V is equals to 1 upon N r to the power 2 by 3 s to the power 1 by 2. So R is called hydraulic radius. R is equals to wetted area by wetted perimeter. Wetted perimeter. So if I take rectangular, because it is easy to explain, this is the height, this is the width. The total height is T, that open channel flow. So the wetted area is H into W. Wetted perimeter is W plus 2H. So this is the hydraulic radius. For circular sewer, R is equals to A by P. So circular sewers, let's calculate it for full flow. Full flow. This is the dia. Area is pi upon 4 d square. Perimeter is pi d. So hydraulic radius is d by 4. So if we want to calculate it for half flowing, flow is at d by 2, means this is the sewer, this is the flow. So in that case, R will be same, because it will be A by 2 and P by 2. So it will be same A by P. R will be P by 4. But in other case, But in other cases, we need to have this. Suppose if the depth is less, if sewer is, if the depth is, let's take an example, it's d by 3, we need to have this angle. This is theta, I'm taking it as theta by 2. So I should have this angle theta by 2. And then subsequently I need to calculate this whole area, and so I need to know this value and this area. So that R will be A dash by B dash. This is the area, this whole area and this whole perimeter. Sorry. Wetted perimeter will be. There is a mistake here, so I will write it here again. So this perimeter will be this much only, and area will be this much. This much area and this much perimeter. Mathematically we will calculate. So now we will calculate about discharge. So how much discharge will come? Let's take, so discharge has two components. Let's see, it may have other components also. Let's see. So one is from stormwater. Stormwater will come for a small duration, and another one is from domestic wastewater. Domestic wastewater. Yeah, the discharge had two components. One is stormwater, that is for very small duration, but at that time, for a small duration, that discharge is high. High discharge. So discharge here has two components. One is stormwater. That stormwater means rainfall that is for a small duration, and it has high discharge, and it is calculated with the help of hydrology. Domestic discharge, domestic wastewater, and other component can be industrial wastewater. Industrial wastewater. Industrial wastewater sometimes. It is sometimes mixed with the domestic wastewater. So we studied earlier, this stormwater can be combined with this domestic sewers, and this stormwater can have separate drainage pipe. Yeah, we studied separate system, combined system, and partial separate system. So for these three also we can have three separate pipelines. So how much discharge will come, that we'll see. So this can be calculated through hydrology. So in hydrology, what we are doing? So let's take this is a catchment. Catchment. This is called catchment area. These are called ridge lines or water divide. So the water which will fall in this region will go to this area. That we will calculate. This discharge we will calculate. And this domestic wastewater we will see. So this domestic wastewater, or we can say it residential or municipal wastewater. I forgot to mention in the last slide. So it is governed by this stormwater. Stormwater is governed by topography area, land use, land use or land cover. I can write here green cover, or I can write type of soil, permeability of soil, because it is mostly which is coming here. Q, that is runoff. We studied earlier. That is runoff. There are few factors which govern the stormwater. How much paved area we have, how much paved area. So this was about stormwater, and it is calculated with respect to rainfall. So rainfall which happens, some part will infiltrate, some part will be stored in depression, some part will be taken up by plants, that is called transpiration. Some part will be evaporated from the water bodies, depression, storage, evaporation, and whatever the leftover will form runoff. So this runoff will that will go into this runoff will go into the stormwater drainage. Stormwater drainage. Now we will talk about domestic, residential, or municipal wastewater. So this wastewater, how it is generating. So we understood in the previous lectures, like from the service reservoirs, we are sending the water to the distribution system. We are sending the water to the community. This community is consuming the water, and then it is producing wastewater. So this wastewater, so this water consumed, so how much wastewater will be there? Let's write it down. So wastewater from households or community is goes to water water supplied water supplied minus water consumed. We will see what are the components of water consumed. So let's write it down. Water. In the next slide I will write. Sorry, in the previous I will try to. So households, how are they consuming the water? Water consumed by the community. These are drinking, bathing, bathrooms, toilet, gardening, road cleaning. Okay. So these are for these purpose, the households, the community will utilize water for drinking, bathroom and toilet, gardening, road cleaning, and there can be some leakages and losses. So water consumed, we can say minus water consumed, then some losses. I'm writing it here also. That is not a big problem. Some losses. Okay. And sometimes losses from sewers. Fine, that will include there. There is one more factor which will come, that will be plus minus. Sometimes you can understand it like this. Sometimes this is groundwater table. Sometimes if groundwater table is below, so increase due to groundwater flow and decrease due to flow into the soil. So this part is above the groundwater table will enter inside, and sometimes this is above, so the wastewater will come out of this. This is the concept. Wastewater may come out, that is loss. So this is the wastewater. This is the discharge we can take. Now we can proceed with few questions. So mostly sewerage systems are gravity based, but in some cases we can use pressurized sewer systems and vacuum sewer systems. For less rainfall, which type of sewerage system is used? For less rainfall, we use combined system, because if there is less rainfall, we can combine the rainfall water with the sewer system, and if we don't do that, then we have to uh, make extra drainage pipelines, which will cost us more. So rather than uh, constructing extra pipeline, we combine the drainage part in with sewage, and we treat it with sewage. We treat them in we treat the combined sewage with uh, in sewage treatment plants. That is a cost-effective technique. Which of the following is disadvantage of a combined sewer system? So the disadvantage is it overflowing of sewers during heavy rains. So when heavy rain will occur, because the assumption was because we design sewer system by assuming less rainfall. That's why we provide, because we design combined sewer system by assuming the less rainfall and less less stormwater discharge. For heavy rainfall, which type of sewerage system is used? For heavy rainfall, separate system is used. Which of the following is not a type of water carrier system? So these are water carrier system, but this is not a water carrier system. So this is correct. In which type of water carrier system is stormwater allowed to enter into the sewage system partially? So this is partially separate system. So in which the water from rooftops and paved areas is allowed to mix with the sewage pipeline. That is partially. What does the peak factor represent? Sewage flow calculation. So the peak factor means maximum flow to average flow. Peak factor means maximum flow by average flow. CPHEO manual recommends that rain gauge density in cities with a population more than 10 lakhs should be 5 to 10 kilometers square. So what are rain gauge? Rain gauge is nothing but an instrument which has funnel kind of thing which is used to measure rainfall. So it has a fixed area. It has a fixed area to collect rain, and that it is measured. It gives the rainfall in terms of depth. Gives rainfall in terms of depth. Flow in sewers is a function of. So the flow in sewers is a function of population served, how much population is consuming and discharging wastewater, population density, and water consumption, and how much they are consuming. So it depends on all the factors. Unauthorized and authorized entrance sources of discharge into sewers. This we discussed. So water supplied by our urban local body to domestic, industrial, and various public uses. So this is the uh, water supplied, and water drawn from other sources such as wells, tube wells, lakes, rivers, and water entering the sewers through cracks and leaky joints. So through cracks and leaky joints also the water may come out and come inside. Depends upon the height of water table inwards in vulnerability. So there we can add one more thing. Water supplied plus water used from wells, rivers, or lakes. So if they are consuming water from their bore wells, rivers, and lakes, then it will also impart into the wastewater. It will add on. In arid regions, sewage flow is this much percent of water consumption. So that this is 40% of water consumption. 40%. 40%. Net quantity of sewage equals to accounted water for water supply from the water works which supplied additions due to unaccounted private water supplies. Let's take an example as wells. Take it as wells, private wells, and then addition due to infiltration. So if it is placed below groundwater table, below sewer is below groundwater table. Subtraction due to water losses because of leaky joints and all. Subtraction due to water not entering into the sewerage system. So that is water consumed by the community. Consumed by the community. Which of the following statement is true concerning sewer design? Lateral and submain sewers are usually designed for average flows of the population. Lateral sewers are designed for peak flow, and some main sewers are designed for average flows of the population. Lateral sewers are designed for the average flow, and some main sewers are designed for the peak flow of the population. Lateral and some main sewers are usually designed for the peak flow of the population. So this D1 is correct. All sewers are designed for the peak flow. When is it necessary to separate sewage from stormwater flow? That we already discussed. In case of heavy rainfall. In case of heavy rainfall. In absence of actual data on sewage flow, a typical value of this is used while designing a conventional sewage system. In absence of actual data from sewage flow, a typical value of 100 LPCD is used. A seasonal maximum flow rate of sewage flow is this much times of average flow rate. That is 1.3 times of average flow rate. Rainfall intensity index is ratio of observed rainfall intensity to the ratio to the rainfall intensity which will cause flooding. Ratio of rate of incoming storm flow to the rate of pumping rate. Ratio of total flood prone area to the total area. Percentage of catchment which is impervious. So the rainfall intensity is A, means the ratio of observed rainfall intensity to the rainfall intensity which will cause flooding. So how much is the rainfall intensity and the intensity which will cause flooding? Sewers should be laid above or below the groundwater, uh, above and below the ground. So okay, this question is about the below the water supply pipes. So they are asking these are water pipelines, these are sewer pipelines, or these are sewer pipelines, these are water pipelines. So which one should be the ideal case for us? So these are water pipelines, these are sewer pipelines. Oh, sorry. It should not be made like this, it should be made like this. Why? Why opposite direction? Because from a household, let's make it here. It will produce and it will pipelines, sewer. So because of this thing, like this. So this should be the ideal case because if any leakage happens in the sewer, if any leakage happens in the sewer, it will not go up. It will not affect the water pipelines. Whereas if any leakage happens, this will come down. This and it can intermix with the water supply. So that happens most of the time. So here I can write leakage affects the water quality of the water supply. Whereas in this case, it won't affect, but it will affect if sewer, uh, sewer, this sewer, it will affect only when a certain capacity is reached. When the height of water level will increase, then it may affect. Otherwise, if there is small leakage, then it won't affect the drinking water supply, we can say. So, sewage mixing index, rainfall intensity index, system robustness index. So, ratio of volume of sewage in stormwater. So, this is sewage in stormwater. How much is the volume it is in stormwater? That is called sewage mixing index A3. Rainfall intensity index that we studied, ratio of observed rainfall intensity to the ratio to the rainfall intensity. So B is 1, C is system robustness index is ratio of incoming storm flow to the rate of pumping. So C is 2. This is the answer. So robustness is decided based on how much uh, ratio of rate of incoming storm flow and rate of pumping. So it should be less or more. It should be less actually. This is the answer. What is area vulnerability index? Area vulnerability index. So this is the total flood prone area to the total area. So let's take this is the total area and this area is near the river. Let's take it can be near the river also. So this area is flood prone area and this is the total area we are assuming for a watershed. So this is called this area divided by total area, that is B, is called flood prone area to the total area. This is called vulner, vulnerability index. And in and we can take one case because of the drainage also. Because of the drainage also, sometimes drainage gets choked. Sometimes choked drains may cause floods. Floods in the cities. that can also be during rainfall. So it's not like it's only due to the rain, due to the river. It can be due to the rainfall also in the cities, because we have paved areas there, and in the paved areas, if the water is not channelized into the drains, and even the drains are choked with the plastic and all the waste, so we need to count that area as a flood prone area. And so that's why in lectures also sir has mentioned about the waste, how much waste we are disposing, or waste needs to be calculated, and that waste management has to be done properly in order to avoid flooding conditions. So in this lecture we studied about the sewage, stormwater and sewers. So we know sewage has main component, that is black water, that is from toilets, and it also includes kitchen and bathroom wastewater. And the stormwater is mainly due to rainfall. And then we studied about the type of sewerage system. So there are three types. I will write it here. Types of sewerage system. One is combined system, separate system, and one is partially separate system. So this is about combined system. This is about separate system. Combined, separate, partially separate. Correct. So then we studied about why sometimes separate, why combined, because wastewater contains organic matter. That's why we need to treat it properly. Whereas the stormwater or drainage can be directly discharged into the river water bodies. Then we understood for sewer design what all things we need to consider. That is shape, type of flow, how much slope to give. We are providing gravity flow, what type of material, discharge and fluctuations in the flow, and type of sewer system that we already studied. So these things we studied, like this is the atmospheric, only atmospheric pressure will be exerted on the surface of water. So that's why it's called open channel flow, and it flows under the influence of gravity. This is the main point which describes the open channel in the sewers. And this velocity in the open channel can be calculated using Manning's equation. This is Manning's equation. Manning's equation. So this n depends on the material. Depends on material. So if the material is smooth, for a smooth material, for a smooth sewer, for a smooth sewer pipe, n should be less or more. For a smooth pipe will have greater velocity, so n should be less. For a smooth pipe, n value is less. And then we talk like mostly we use circular sievers. So we calculate R, that is hydraulic radius, that is D by 4 in two cases when it is flowing full and second case when it is flowing half. And then we studied about the discharge. So the discharge is from is uh, can be due to stormwater and domestic wastewater, and then sometimes industrial water wastewater can be added into the domestic wastewater, and it can be combinedly treated. That will go into the CETP, common effluent treatment plant. When it both will be combined, then it will combinedly go to CETP. But if it is not combined, when it is not combined, separate sievers for all three can be provided. It depends on our requirement. So that we discussed how many what factors stormwater is governed by topography, land use, and green cover. And this domestic wastewater, uh, so it is called by other names also, residential and municipal. And then we discussed how the wastewater is produced from the community and how much fraction of it goes into the sewage. Yeah. And then we studied water supplied, water consumed, and then what increment, what decrement in the sewage, and then we solved few questions. So this was about week 8 session. Thank you.